Hello everyone, and welcome to this explainer. I am absolutely thrilled to have you with us today. Now, listen closely, because if you are currently preparing for your Cambridge AS and A-level mathematics exams, I want you to consider this your high-priority Code Red briefing. For the duration of this explainer, I am acting as your elite Cambridge Exam Tower Director, and we are running a full-scale air traffic control exam emergency simulation. Think of the 9709 paper as an incredibly busy, high-stress airspace. And those high-tariff, logarithmic, and exponential function questions? Well, those are the incoming heavy aircraft. You have extreme time pressure, amber warning lights flashing on your console, and a limited fuel-to-mark budget. We aren't just going to talk about textbook math today. We are going to completely decode the examiner's playbook. We are revealing exactly what examiners look for when grading these complex functions, specifically focusing on the laws of logarithms. We're going to completely transform how you approach these high-stakes questions, showing you how to manage the intense stress, prioritize your high-yield marks, and guide every single calculation to a perfectly safe touchdown. All right, strap in, initialize your radar grids, and let's get started.
Okay, let's dive right into this. Look at the crucial question we are tackling today. What truly separates a solid B candidate from an A-star candidate in A-level mathematics? You might think it's just raw, innate mathematical talent, or maybe having every single logarithmic formula memorized to absolute perfection. But the truth, which we've pulled directly from Cambridge Principal Examiner reports, is actually much more strategic than that. The difference essentially comes down to your operational methodology during the exam. When the pressure is on, you effectively have two different types of operators inside your head. On one hand, you have Router Alex. Router Alex is the panicked side of your brain that gets totally bogged down in minor algebraic details, second-guessing simple arithmetic, and ultimately creating an infinite holding pattern that burns all your precious exam time. On the other hand, you have Router Sam. Router Sam is the side of your brain that rushes the process, clearing arguments for landing way too fast without ever verifying the structural safety regulations, skipping the crucial working steps just to jump to a final number. To get that A-star, you have to bypass both Alex and Sam. Today, this explainer serves as your insider's guide to doing exactly that. We are going to build a solid framework that not only gets you the correct final answer, but definitively proves to the examiner that you truly understand the deeper architecture of the math.
To get you operating at that elite level, we have a highly structured flight plan for today's session. First up, we'll initialize with the A-star math mindset. Second, we will route the approach vector by looking at the core theoretical foundations. Third, we'll dive into the tactical stuff with the procedural solution sequence. And finally, we will open up an interactive runway workshop to cover the top 3 examiner warnings. Let's jump straight into Phase 1.
Phase 1, the A-star math mindset, bridging the gap. This is where we completely reprogram how you perceive these exam questions.
Making the jump from a respectable grade to an A-star requires a fundamental, ground-up mindset upgrade. And this brilliantly illustrates exactly what I mean. On the left side, we have a closed book, which represents the standard, middle-of-the-road approach. This is relying purely on isolated topic memorization. This is our Router Alex approach. This is the student who memorizes the basic rule that the log of A times B equals the log of A plus the log of B, but sadly, that's where their application completely stops. They just have a flashcard in their head. But on the right side, the brain with the connected puzzle pieces illustrates the true A-star approach. This is all about connected, conceptual understanding that is highly transferable to totally unfamiliar contexts. A candidate with this mindset doesn't just know the formula, they know exactly how an exponential growth model in a weird real-world word problem suddenly requires those logarithmic laws to isolate the time variable. They instantly recognize when they need to linearize a complex curve using logs to find an unknown constant. They see the whole radar screen, not just one blip. This cross-topic connectivity, this ability to pull tools from different parts of the syllabus to solve a single high-tariff problem, is exactly what the examiner is actively looking for when they are scanning your paper.
Let's map out this approach layout based on the explicit assessment objectives set by the exam board. The exam fundamentally targets 3 distinct cognitive domains, and you need to clear all of them. First, you have knowledge and understanding. This is the baseline. This is simply knowing your log laws and exponential properties. Second, we have application. This means you can use those formulas in a straightforward, familiar mathematical context. But the third domain? This is the absolute holy grail for examiners, analysis. This is where Router Sam usually crashes and burns. Sam has the knowledge and tries to apply it, but skips the deep analysis. Listen to me. Simply knowing a formula is never enough to secure top marks in a Cambridge paper. You have to rigorously analyze the given data, determine precisely which mathematical laws apply, and actively evaluate the relationships. For logarithmic and exponential functions, analysis means you are interpreting the complex relationships between variables when they are deeply buried inside massive walls of text or complicated tables, and then thoroughly proving your methodology on the page. You have to show the examiner exactly how you track the aircraft from the edge of the radar all the way to the runway.
Phase 2, Core Theoretical Foundations, Building the Architecture. This is where we make sure your mathematical aircraft has the structural integrity to survive the high-pressure environment of the exam room.
So what exactly do we mean by theoretical architecture? Well, it is a conceptual framework resting on precise definitions, causal relationships, and integration with other syllabus areas. I want to zero in on that phrase causal relationships. Principal examiner reports show that they specifically and consistently reward candidates who systematically reference these relationships in their working. Let me give you a concrete example. Because the exponential function is the mathematical inverse of the logarithmic function, we can purposefully apply the natural log to both sides of a complex equation to bring down an unknown exponent. That right there is a causal relationship. You aren't just performing some random magic trick you memorized from a textbook, you are strategically applying an inverse operation to solve for your specific target variable. When your written working clearly shows the examiner that you understand the fundamental why behind the how, you are essentially locking your marks into the system. You're proving that the math isn't just happening to you, but that you are actively commanding the math.
Tower transmission check. We are pausing the radar screen for just a second. Before we clear this next response for touchdown and get into the real tactical strategies, I need to ensure your transponder is fully updated. Go ahead and subscribe to Ace the Exams at the handle @AceTheExams right now, and make sure you turn on all notifications so you never miss an emergency exam briefing. Okay, transmission check complete. Let's resume. Welcome to Phase 3, the procedural solution sequence. This is your ultimate method mark strategy.
Now, what's really interesting about this slide is that the method mark strategy is arguably the single most critical concept in this entire explainer. It is the absolute core of our fuel to mark budget formula. Look closely at this definition. It's the examiner's practice of awarding marks for a correct, systematic process and logical steps completely independent of the final answer. Let me repeat that because it is a total game changer, independent of the final answer. Imagine you're working through a massive 5-mark exponential decay problem. If you accidentally drop a negative sign in the very final line of your calculation because you were rushing, but your underlying methodology, your initial application of the laws of logarithms, was perfectly structured and meticulously documented, you will still harvest the vast majority of those points. Proper, visible methodology matters just as much as getting the final number right. This is exactly how you manage your extreme time pressure. You don't panic if the final arithmetic looks slightly messy, you focus on securing those high-yield method marks by proving your logical process.
To absolutely guarantee that you capture every single one of those method marks, you must rigorously follow this standardized sequence. This is your perfect glide slope. Step 1. Identify key elements from the prompt. Separate the signal from the noise. Step 2. Apply relevant principles. Ask yourself, which specific logarithm law is actually needed here? Are we looking at the power rule, or is this a quotient rule situation? Step 3, execute the analysis with incredibly clear step-by-step working. Do not, under any circumstances, let Router Sam convince you to skip steps in your head. Write them down. Step 4, verify your results against the initial constraints. And finally, Step 5, present your answer in the appropriate format. If the question explicitly asks for 3 significant figures and you just casually write down 2, you are needlessly bleeding points right on the runway. Following this strict 5-step sequence proves to the examiner that you are the one in total control of the airspace.
We can distill that massive sequence into a highly effective 3-part problem-solving methodology. Think of this as the ultimate formatting template to guide your math back onto the glide slope when you encounter an unexpected structural block mid-calculation. It's deconstruct, solve, evaluate. It's basically your classic Peel writing template, but perfectly adapted for high-level mathematics. First, you deconstruct the data. You extract the vital, numerical information from the text or the graphs. Next, you break the problem into logical, bite-sized steps and solve it systematically, explicitly showing those log laws in action. Finally, you evaluate. You check for reasonableness. Let's say you are calculating an exponential decay model for a cooling cup of coffee, and your final answer suggests the coffee is going to reach absolute zero in 5 minutes. Your evaluation step should immediately trigger a massive amber warning light in your head. You must make justified recommendations based on the evidence. This tightly structured sequence is exactly how you interpret highly complex relationships without letting the exam pressure overwhelm you. We are now entering Phase 4, the interactive runway workshop for viewers. We are looking at the top 3 examiner warnings, and we are going to learn how to navigate the trapdoors.
I want you to look at the stark concentration of lost marks on this visual. We're doing some live audience tracking here. Imagine this is a data map of every crashed grade from the last 5 years. Direct from the principal examiner reports, the errors fall overwhelmingly into these 3 massive categories. This is the debris on your runway. Number 1, confusing cause and effect. Number 2, poor formatting and presentation. And number 3, providing generic answers. These are the 3 things that will cause you to fail your safety inspection. Let's break these down in detail so you never make these critical mistakes.
All right, let's isolate these trend variables. Warning number 1, confusing cause and effect. Examiners report constantly that students under pressure will often apply a law of logarithms completely backwards, or they will panic and mistake the input of a function for the output. You have to be precise with your bases and arguments. Warning number 2, forgetting to check format, terminology, and clear annotation. Look, mathematical presentation follows incredibly strict safety conventions. If you don't use proper headings, or if you abandon correct mathematical terminology halfway down the page, the examiner literally cannot follow your logic, and you immediately lose those precious method marks. Always clear your structural blocks and make your working painfully obvious. And warning number 3, which is by far the biggest danger zone on the entire radar screen, providing generic answers without context. This is where router Sam strikes the hardest, just throwing down a memorized definition without actually reading the specifics of the flight path. So the crucial point is captured perfectly, right here in this quote straight from the examiner's insights. Listen to this. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Let me give you the classic example. If a high-tariff question asks you to interpret the constant k in the standard equation p equals p sub 0 times e to the power of kt, representing population growth, do not just blindly write down k as a constant multiplier. No way. That is a generic autopilot answer that violates safety regulations and drops points instantly. You must contextualize it. You have to explicitly state k represents the continuous relative growth rate of the population per year. Context is absolute king here. You have to contextualize your mathematical evidence to successfully evaluate the scenario and draw valid, high-scoring conclusions. Okay, before we clear you for your final safe touchdown, I have an active memory hack challenge for you. Right now, I want you to lock these vital techniques into your long-term memory for your upcoming exams. I want you to create your own mnemonic using the first letters of the key terms from today's framework. We have deconstruct, solve, evaluate, and contextualize. DSEC. Maybe you use something like don't skip every context. Or perhaps data solves exam challenges. Whatever specifically works for your brain, I want you to literally write it down on a piece of paper right now. Because when that exam anxiety hits, when the clock is rapidly ticking down and the pressure is completely overwhelming your system, repeating this simple mnemonic will instantly reset your focus. It will shut down router Alex and router Sam and put you right back on the perfect glide slope to securing full marks. Let's end with this final provocative thought to take with you back to the terminal. If examiners explicitly value your process over isolated answers, if they are actively looking to give you those method marks as part of your fuel to mark budget, how are you going to restructure your very next practice paper to undeniably prove your methodology? Really think about it. The next time you sit down to solve a nasty logarithmic or exponential function, don't just panic and rush to the final number. I want you to treat your exam paper like a professional, highly structured air traffic control report. I want you to go apply this systematic approach immediately. And hey, make sure you subscribe to Ace the Exams at the handle @AceTheExams and absolutely enable that notification bell so you never miss another emergency briefing. Also leave a comment down below sharing exactly which math paper gives you the absolute most anxiety, and we will tackle it together in a future session. Thank you so much for joining me on the Explainer today. Keep running those past paper simulations, and I'll see you in the next one. Clear skies and good luck.